All right, there seems to be some interest in the couple of videos I did on Forth programming, F-O-R-T-H, Forth. And so I thought I'd tell you a little bit about the language, which I find fascinating. First of all, it was invented by Charles Moore, Chuck Moore, who's pretty famous. And he was working on a programming language, I think, for personal use. And this was kind of the fourth revision, so he named it that. Spelled it funny, but named it that. And it is sort of an interpretive and compiled language both, and we saw that in some of the videos. Let's talk a little bit about programming languages. If we have a assembly language program, then we would have instruction, instruction, and we'd have a bunch of instructions, and it operates that it's going to execute each instruction. And so there's a program counter in the microprocessor, and it keeps track of where it is, and it just goes step, 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 step. All right, so in a higher level language, like BASIC, you have instructions which are actually ASCII characters. And so you would have something like some type of instruction. Instruction 1, instruction 2. And you would actually store the characters INST1, INST2. And what the basic interpreter has to do is it has to find this string in its file system, or in its programming system. It has to find a match for instruction 1, and then it has a code that it executes when it sees that instruction 1. And then there's instruction 2. It would have to keep track of where it is. It would then have to increment to the next instruction. And so it would have to keep track of where it was in the ASCII characters, and it would know that there's a return at the end of the line, and it said, oh, okay, that's the end of the line. I'm going to interpret these characters, and then I'm going to do the next instruction. So it requires a whole bunch of processing to try to figure out what that word is. That's what's meant by interpretive instead of compiled. If it was compiled, then everything would be converted into assembly language and put in there. That's what C does. C takes a bunch of ASCII characters as the program and converts it into assembly language programming. Okay, so let's talk about Forth. So first of all, in BASIC, we could have a bunch of instructions, or we could have a subroutine. And so we could create a subroutine, which is a series of things to do. And we have a label for it, so we would say go sub subroutine 1, right? And then we might have another one, go sub 2. So you could execute a whole bunch of subroutines, and that could be a program. And again, you have to have all of this ASCII characters and everything. So what is this really doing, though? This is actually, sub 1 is an address, and it tells BASIC, go to that address, execute that code, but then come back here and go to the next one. So what if we just put in a bunch of addresses? What if we had some programming language, oops, ADDR, address 1, address 2, address 3. What if all we did was have a list of addresses? Address 1, address 2, address 3, and that's our programming language. And the programming language knows to point here, and there's going to be address here, just 16-bit value of address, and it's going to take that address. It's going to know that there's there's a subroutine at that address, so it's going to go execute that subroutine, and then it's going to come back here and it's going to go to the next line. And again, here's a 16-bit address. It knows that's some code someplace, and it's going to go there and do that. So all you have to have is just a list of addresses. Well, that's what forth does. Forth is just lists of addresses, and it keeps track of where it is. So it takes this value, it executes it, and it comes back and increments the counter, and it just keeps going around and around and around. And so that's basically a forth program. And we can then create words. Like, remember, we had like nickels and pennies and quarters and things like that, and those are words, and those words do things. And so when we create a new word, we say something like colon. Colon says, I'm going to want to create a new word, and we'll say nickel. And it says, okay, that's the name of the new word. And then you're going to say 5 multiply. Okay? And that is what we want it to do. So what does forth do when it sees this? It puts a new entry into the dictionary, nickel. So somewhere in forth is the dictionary. Okay? Dictionary. And it's going to put in that text nickel. So it has the text in there. So if in forth you ever type the word nickel, it goes through the dictionary one word at a time and looks for a match, and it says, okay, you typed nickel and I have a match for nickel. Okay? And then there'll be some other things in the dictionary. Maybe there'll be another word down here that, say, is quarter. Okay, and that's also a text string. And there is in the dictionary, you have this text, and then you have an address here. Okay, you store a 16-bit address, and that address actually points to here. Okay, so when you execute words, it has to look them up in the dictionary, and it's going to start at the very end of the dictionary, the very latest word, and it's going to go through all of the words in the dictionary until it finds a match. So let's say we typed nickel. It's going to start here. This is the last one. It says, is it quarter? No. So what does it do? It says, I'm going to use this address to go, it's going to tell me where the next word is in the dictionary, and it's going to point here to nickel. Okay, and if it's nickel, then okay, we're gonna do something else. But let's say we typed penny, and that's not either quarter. It's going to come here. That's not here. So then there's another address under nickel that then points up somewhere in the dictionary, and it'll just keep going and keep trying to find some match of ASCII. Okay, so that's kind of the dictionary structure. That there's a text, and then there's an address that links all of these words together. And then, if it actually is nickel, then we're going to put code here. Okay? So, code is going to be in this space here. And quarter will have its code here. Okay? Now, in forth, code can either be assembly language. You can actually have assembly language. Or you can actually do this new funny thing, which is just a bunch of addresses. Address, address, address. And maybe quarter would just be address, 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 address. Right? And so forth can store things either way. It can either be ASCII, not ASCII, it can be actually assembler code, actually executable 8080 assembler code, or it can be just a list of addresses. So it will go to address, the first address, it'll do that, it'll come back, it'll do the second address, do that, it'll come back. And That's the way this dictionary is built. Okay, so let's go look to see how this works. We'll look at the actual version of Forth. There is one other thing you need to know before we do that, and that is up a bit. If the code is just assembler, then it's fine. You just put in the code. But if it's these addresses, how does it do that? How does it get an address, go there and come back? There has to be some type of little program that just does that, that knows how to go get an address, knows how to execute that, knows how to come back, knows how to increment. Forth is going to call that little program next. Okay? And next is a very special little program in Forth. And what next is going to do is it's going to increment the counter, fetch an address, and then jump to that address. That's all it's going to do. So let's say we were here, and we know that we're going to be running a bunch of a bunch of addresses. And so what we're going to do is we're going to increment the counter. That will put us here. We're going to fetch the address. So we're going to grab this address. Okay? And then we're going to jump to it. All right? And then when we finish with that, it's going to come back here again. And it's going to go to that address, increment the address, get that address, and then jump that address. And it's going to do this over and over again. And there's going to be this little program called next that does that. Okay? So let's go take a look at Forth, and I'll show you how that's implemented.
Hello, testing. Okay, so we're looking at an assembler listing for FigForth. This is one of the earliest versions of Forth written for the 8080. And I don't know, is the date? Oh, there's a date on here, 1979. And there's a bunch of words here. Let's get to the actual source code. It's down a bit here. Okay, so we're into source code now. And here's the origin. Remember, everything in CPM lives at address 100 hex. So one of the first things we're going to be taking a look at is what registers are used in the 8080. Now remember, the 8080 has register pairs, so it can actually execute 16-bit registers by using register pairs. And so we're going to have several registers used in Forth. One is called IP. This is the interpretive pointer. This is the pointer that I was kind of alluding to on the paper there, that's going to be pointing to addresses and being able to keep track of which address are we talking about. All right. There's a W register that I really don't remember what it's used for, but we're going to use, so the IP register, we're going to use the BC register pair. W, we're going to use the DE register pair. And then also remember, Forth has a stack. Remember how we use the stack? You could say like 1, 2 plus, and 1 goes on the stack, 2 goes on the stack, and then plus takes those two things off the stack, adds them together, and puts that back on the stack. So you have to have a stack and Forth. So we're going to go ahead and use the actual 8080 stack pointer and stack to do the stack stuff. So the other ones are sort of like stacks. Unfortunately, we don't have more than one stack in the 8080, so we have to create our own stack, W and an IP. Okay, so let's go down a bit. So here is that little bit of program called next. Remember, next has to increment the counter, it has to fetch from memory, and then it has to take that address and actually go there. So how's it going to do that? So if we enter here at next, it's going to take a value that's being pointed at and put that into W. Um, where you're being pointed at is where you were last, which address you were last pointed at. Um, we're going to take the pointer and add 2 to it because we're running in 16-bit value, so we're going to add 2. So we've incremented the IP register, and then we've remember that's operating on the BC registers. And then we're going to take the A register and load that into L. Interesting. We're going to increment the B register. So I don't really quite sure how this works, but this is the important part. It's incrementing the program counter. It's then taking the value that's pointed to, and it's going to get that from memory. So it's these memory fetches, M to E and M to D. So we've taken where we're pointed to in memory, and we've loaded that into the DE register. Okay. Once we have the address that we want to go to in the DE register, okay, we need to put that into the H&L register. So Exchange swaps the H&L registers with the D&E register. So now that address is in the H&L register. And then this particular instruction, PCHL, takes the value of H&L and places that into the program counter. So it's a direct jump. We're loading the program counter with the value of H&L. Okay, so that's how the next operation runs here. All right. So that is the only bit of code that is not in the dictionary. Everything else in Forth is actually in the dictionary. And the dictionary starts immediately. And the dictionary looks like a string, like I said. So the very first word in the dictionary, or actually the very last word in the dictionary, is LAT. It stands for literal. You don't need to know what that is, but LAT is a word in Forth. And then there's some stuff. And then the next word is execute. And then there's some stuff. And then the next word is branch. And then there's some stuff. Okay, so remember I talked about that the ASCII values in the dictionary are here. So here's branch, right? So if this is all the dictionary there was, we would start here at branch, we would type in a new word, and it would check it to see if it matches branch. If it matches branch, then it's going to execute this code down here. If it doesn't match branch, then it has to go to the next dictionary entry, and it uses this address that follows immediately. It says the address is execute minus 0AH. So EXEC minus 10, okay? So here's EXEC minus 10. Let's count. This is the data word, so this is 1, 2, and then there's some ASCII characters, 3, 4, 5, 6, 7, 8, 9, 10. And so this says, okay, if it's not branch, we come up here, and now we're pointing to this directory entry. If it's not that one, then it's going to use this address, which is lit minus 6. So here's lit, and then let's count. 1, 2, 3, 4, 5, 6. So now we're pointed here, right? And if it's not lit, then it's going to go to, oh, it has a 0. 0 marks the end of the dictionary. So it's going to go through this list of words, this dictionary list, and it's going to go through them until it finds a match, or it doesn't find a match and gives you an error. So that's how the directory is put together. Now, if it is, so let's say the word that we typed in was LIT, it's going to execute this. So instead of going to this address, it says, okay, I'm going to drop down one. Now this tells me what to do. This tells me where I should go to actually do something. And it says, take where I am and add to. So it just bumps down. It says, here's your code. This is what you should do. And here's your inline assembler. It's going to execute these assembly languages things. And then guess what? The very last instruction is jump H push. Okay, that's interesting. Well, what's H push? We haven't talked about that. Let's go down to the execute one. Again, we would execute a pop instruction, pop H, and then we jump to next one. Okay, that's interesting. Next. Remember, we wanted to jump to next. Um, Here's a branch command. And if the branch command, it would do these things. And then the very last instruction here is, oh, jump next. Okay, so that sounds more like what we want to do. We want to always be executing that next command. So every time we do something, we need to jump to next. The next makes sure that we increment, we grab, and we do the next thing. So next is at the end of every single word. So here's another word, branch, zero branch, jump next. Here's something called loop. Loop keeps going, and then what's the very last thing? Jump next. Okay, so there's always going to be this jump next in there somewhere. Okay, here's another jump next. Now, sometimes it wasn't jump next. Sometimes it was jump or push or things like that. So if we go back up here to next, we might want to do other things. We might want to do uh, a push H before we do the next, or a push D and then push H before we do the next. So you could have it do a little bit extra because those are used very, very often. Instead of putting them in the code all the time, they've just added them in front of the next command here. So you can point to, say, H push instead of doing your own H push and then jumping next. It just saves a little bit of overhead. And then sometimes maybe you don't want to do something, you just want to do a jump, a next one. Next one is just saying, take what's ever in memory and go there, right? So next can be used in several ways, but in general, let's just kind of have in your head that every word ends with jump next, okay? And so you have a bunch of inline code, then jump next. A bunch of inline code, and then jump next. Okay, so that's the way words work that are compiled. Um, let's see about the words that are actually a bunch of addresses, lists of addresses. So those are more complicated words. So let's go way up here in the dictionary. And let's see if we can find one that's kind of interesting here. Fill command. Um, that one is in line assembler. Uh, okay, well, here's one that we can just kind of use. Um, this is called Word. So I don't remember what it does in Forth, but WORD. So if you typed in Word, it would say, I've got a match. And so remember how this line used to say, where I am plus 2, and then it would start executing code. It doesn't do that now. What it says is, it says, this is a type of word that I've created with a colon. Remember, like nickel was colon nickel, and then things to do. Well, if you have entered something with a colon, then you start everything with do colon. Do colon basically tells Forth, okay, you're going to have just a list of addresses now. Okay, so do colon, it's like how we've started our word, started with a colon, and then we're going to execute a bunch of subroutines, right? So this is the address for BLK, the address for at, the address for zero branch, the address for, BLK, at, block. Anyway, it's going to execute each one of these little subroutines. So these are just addresses, a list of addresses. And it's going to keep going down. Here's a plus command. Um, there's things called literal. Remember we did that LIT? Literal just says, I have a literal and it's 22H. So remember my nickel where I had 5 times, that if you looked at the definition for nickel, that it would say lit 5, which means there's a literal 5. So it's going to put 5 on the stack, and then the very next one will be multiply, right? So that's how a nickel would work. There'd be a lit 5, multiply. And here, like this one has a subtract in it. This one has a plus in it. And then at the very end, instead of jumping next, we're going to go to something called semicolon. Okay, it's semi-s. And semicolon basically does some cleanup and then does the jump next. Okay, so we start with do colon, we end with semi. Um, and that's the way this thing works, is just a list of addresses and then jump next. A list of addresses and then jump next. And that's the whole dictionary. And if I show you all of this, this is Forth is nothing but a dictionary. It's nothing but a dictionary. except for one little bit of code called next. Very efficient, very clever, um, and it's why it can be both interpretive and compiled. When you compile something with colon, it adds to the dictionary, and otherwise it's just going to take whatever words you've typed at the console, look them up in the dictionary, and execute them real time. So yeah, it's a neat little program.